Tonight in Arkansas, there's a mother tucking in her daughter and turning off the light. A business owner's burning the midnight oil. An at-home dinner date is plating up possibility. And it's all happening under one roof. How? The power of a conversation, like the one John from Integrity Solutions had with First Horizon Bank about his vision for a sustainable mixed-use building. Now it's not just words, it's life. First Horizon Bank. Let's find a way. Go to firsthorizon.com/John. First Horizon Bank, member FDIC.
Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello and thank you for joining us on the podcast known as Space Nuts, where we talk everything astronomy. My name's Andrew Dunkley, and joining me as always from the Australian Astronomical Observatory is one Fred Watson. Hello, Fred.
Hello, Andrew. How are you going?
Good, but you're not at the astronomy location at the moment. You're at a motel.
Absolutely. Although I'm close to the Australian Astronomical Observatory. I'm in a motel room in Coonabarabran where I've been all week.
Yes, and the reason is because you've been involved in a thing called Stargazing Live. We'll talk about that in a moment. We'll also be talking about ancient oxygen that's been discovered, or remnants of. And we've talked about the GRACE satellites in the past and how they've become defunct. Well, the satellite that's to replace them has been launched, I believe. And a question from last week's podcast about the acceleration of the universe. And someone's come up with an idea as to why that might be the case, Fred. So we'll put that question to you a little later. But Stargazing Live, it's a collaboration between two national broadcasters, that of the BBC and the ABC here in Australia. Now, and you've had a busy night of it. You look quite jet lagged, to be honest.
Thanks, Andrew. That's the best compliment I've had all day. Yeah, it's so actually the show has been running as we speak for 2 nights. It's a 3-night show. Goes to air live from 8 till 9 Eastern Australian time, with a kind of a second program coming afterwards for half an hour, something called Back to Earth, which is where some of the people who've been on the show get around a coffee table and thrash out a few big questions and answer emails and things of that sort. So the history of this program is quite interesting. It's kicked off in the UK, I think, 11 years ago by the BBC, and it was designed to have a live broadcast that allowed people to find their way around the night sky and basically brought people together via television in different locations throughout the UK and in fact elsewhere in the world. It's hosted by Brian Cox, who is first of all a physicist and astronomer, but now a very big media personality.
Oh, yeah. Yes.
Indeed.
I would imagine that a vast majority of our audience, that's you, me and my mum, do know of Brian Cox.
Glad your mum does. Brian's look, he has such a way with science outreach. He's passionate about it. He is very competent in terms of his knowledge of physics and science generally. But the best thing about it is he's a great bloke. What you see is what you get. Brian is, he's a scientist through and through. And when he talks to us as scientists, it's basically just like any other astronomer that you meet at a conference or something. But he's got this passion for outreach. And of course, he is the master at it at the moment. So Brian is one reason why these shows attract such a very broad and large audiences. And last year, we brought it to Australia for the first time. So, in fact, last year we did 2 sets of 3 nights, one for the BBC, and it was live from Siding Spring Observatory. So we went to air, if I remember rightly, we went to air at 6 o'clock in the morning.
Yeah.
We were having rehearsals at 2:30 and things like that. It was pretty dire. And then the following week we did the 3 slots for the ABC at 8 p.m. ABC Eastern Australian time. And that's essentially what we've done this year. We haven't done the BBC segments. There's a lot of BBC people here because it's a collaborative venture. We have now done the second of the 3 nights. The final night is tonight. I had my little bit last night talking about the Galar survey, which you and I have spoken about before, and did my bit on Back to Earth as well, which was great fun. The really nice thing is the amount of interest that it sparks, and also the amount of media coverage. So the media can't seem to get enough of this thing. So I did a slot for ABC News Breakfast on TV yesterday morning, and I've done many radio interviews.
I actually was doing my breakfast show on the radio, and I glanced up because I do have ABC News Breakfast on my TV screen in the studio, and I went, "Oh, look, it's Fred." So I saw you. I couldn't hear you, but I saw you.
No, it's all right. I didn't say anything sensible, but it was nice to be there. So, and the other thing that this is an unashamed plug, Andrew, but the ABC asked me if I would record effectively a podcast. It's something that you can download on your computer or your smartphone or device, whatever it is. And the idea is it's a tour of the night sky, as it is just at the moment in the Southern Hemisphere. In fact, it's designed for Australia, but it would work for the whole Southern Hemisphere. And it's specially targeted to describe what the night sky is like during the week of Stargazing Live, but it's valid for the whole of May. The idea is you load it onto your device, you stick your headphones in your ears, you go outside and switch it on, and a voice very like the one you're hearing now tells you what you're looking at in the sky. But the great thing is the ABC have done some very clever things with this. So there's animations which will show up on your device, so they illustrate what I'm talking about and let you see your way among the constellations and find the Milky Way and all the rest of it. That's as of yesterday, that had 100,000 downloads. Wow. So that's what I said.
Wow. I reckon if we do 1,000 more episodes of Space Nuts, we might get that many downloads.
No, look, we're working on it, Andrew. We're working on it. But anyway, I'm very happy with that. So if I may encourage Space Nuts listeners not to desert us, because we love you all. But if you want to listen to what's in the May night sky in the Southern Hemisphere, the place to go is abc.net.au/skytour, SKYTOUR, one word.
And for those of you in the Northern Hemisphere listening to us, all you have to do is move south.
And you'll be welcomed with open arms.
Absolutely welcome with open arms. There's no room in the motel where Fred is, because there are 3,000 TV crew there at the moment. But we'll find somewhere for you. But it's been a great venture, and it's really exciting, and it's fun to watch, and everybody has a lot of fun. And it's hosted by the Australian hostess. Actually, she's a comedian, isn't she?
Yeah, she's
in real life.
She's another all-round good person, Julia Zamiro. Yeah, that's right. She and Brian are partners in crime in this program. Julia is terrific. She has warmed to Stargazing Live as though it was, her own invention, and once again, is one of the reasons why the program is so popular. I think it's great that we've got this nice little connection between the ABC in Australia and Brian Cox. So yes, well done, Julia.
Fantastic. And well done to you too, Fred, because I know you've put in a lot of work. Everyone's put in a lot of work, lots of hours, lots of unpaid overtime, lots of really crap food. But it's worth it, because so many people get so much out of it.
I hope so. And I think it's easier for me than the 116 ABC and BBC types who are currently working on the mountain.
And yes, of course, and they've picked such a warm time of year to do it.
Yeah, that's right. Yeah. Indeed.
Now, we're going to keep moving along, because one of the things we wanted to talk about on this week's episode was this discovery about oxygen that seems to have formed not long after the Big Bang, which is quite an amazing discovery, Fred.
It is, that's right. And this is it's a great story which combines a number of different telescopes, including ALMA, the Atacama Large Millimeter Array down there in Chile. And also one of the lead authors is a friend of mine, actually, Richard Ellis, who's a very eminent professor now working at University College in London. So the story is basically that these scientists have observed a galaxy with the elegant name of MACS 1149/JD1. That galaxy has been measured using the European Southern Observatory's Very Large Telescope, which of course we in Australia now have access to. That's been observed and discovered to be a galaxy that we see about 500 million years after the Big Bang. Now that sounds like a long time in human terms, but it's tiny compared with the age of the universe, which is 13.8 billion years. So people have analyzed the galaxy of stars and looked at what chemicals were there 500 million years after the Big Bang. And what you expect to see is not much, because the chemical elements come from later generations of stars. It's stars that generate, things like calcium and carbon and nitrogen and all these things. They're forged inside stars. So it was a surprise to the scientists to find the signature of oxygen in the light from these stars. We do it by breaking the light up into its rainbow spectrum, of course, and look for this barcode of information. So what has been found is oxygen in stars in a galaxy which existed 500 million years after the Big Bang, in the absolute infancy of the universe. Why that is significant is that the presence of oxygen tells you that there must have been an earlier generation of stars to create the oxygen. And that might have been the very first stars that formed in the universe. And looking at the quantities of oxygen that were found in this galaxy, and this is the work that's been done by ALMA, they reckon that the stars that formed that oxygen were in existence only 250 million years after the Big Bang, 250 million years. And that is a tiny fraction of the age of the universe. So it means that star formation kicked in very early in the history of the universe and the formation of these elements like oxygen.
I'm just doing the maths. 1/52nd of the existence of the universe.
Absolutely right. 2%. That's absolutely right.
Wow. Yeah. What is also fascinating about this is we can't see it. We haven't seen it. This is so. How do they know? I mean, they think they might be able to see it in the not too distant future.
Bigger telescopes. That's right. So what you've got is the things that you can see are the stars in this galaxy. Which is, nearly the age of the universe away in its light travel time. So you can see the stars in the galaxy that's seen as it was 500 million years after the Big Bang. But it's the fact that those stars have oxygen in them that tell you that there was an earlier generation of stars, even though those stars cannot be seen because they're too far away.
That's not the cleaner out there, is it?
It's just gone past the window. That's right.
I love podcasting. Anything can happen.
It's either cats or horses usually, but this time it's the
birds.
cleaner.
Oh dear. Yeah, and this is what I guess some people struggle with in terms of our capacity to observe the universe, and we've done it many times in terms of discussion, that we're looking at history. Every time we look up, we're looking at the past.
Yeah, we are.
The further we look, trying to look at the Big Bang itself, if we could look at it and see it, we'd be looking at something 13 million years ago, because the light of that event is only reaching us now. And we're moving away from there progressively. So it's all a bit, it screws with your brain.
It does screw with your brain because there's so many things going on simultaneously. But the bottom line in this one is, it's about the look back time. The fact that when you look at very distant objects, you're looking back in time by a huge amount. It gives astronomers basically an attribute that no other branch of science has, really, apart from perhaps geology, where you're looking directly back at the rocks, ancient rocks of the Earth. But we can look back at events taking place, in fact, back in the early universe, which is quite extraordinary.
And what we are waiting for, as you and I have also discussed previously, is the launch of the James Webb Space Observatory, because they reckon that will be able to see what we're talking about here.
That's right.
This early oxygen.
Yeah, the first generation of stars generating oxygen. That's right.
Amazing, incredible. That's quite a discovery. And we'll hear more about that, no doubt, in future episodes. You're listening to Space Nuts. Andrew Dunkley here and Fred Watson there. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated number 1 by Tech Radar. This is the one I use. I've been using it for a couple of years and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree, and governments are getting more and more interested in what you're doing every day. And so, yeah, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
3, 2, 1.
Space Nuts.
Now we're going to talk about a mission that has launched, which is aimed at doing something a little bit different. We've talked about this in the past as well, regarding the replacement of satellites in orbit, specialist satellites, interesting satellites, Fred. And these new satellites are going to, well, they're going to measure water.
Amongst other things, that's right. I'm delighted to see this, actually. So this is the launch of a pair of satellites. It's a joint US-German project. I think the launch was about a week ago. The satellites are called GRACE, and it's a pair of them. GRACE is an acronym, of course. It's a lovely one, actually. I think it's one of the best acronyms. It stands for Gravity Recovery and Climate Experiment.
Nice.
Oh, GRACE. Yeah, it is nice. But it's not the first one. So the original GRACE, and once again, it was 2 satellites. They were in orbit from 2002 to 2017. So 15 years of work. And what they are about, as you guess from the title, Gravity Recovery, is about detecting basically the changes in the gravity of the Earth as you pass over it, which are brought, and they are due to things like the oceans of the Earth or the mountains of the Earth. You can sense the gravity, the gravitational pull of these different things. The way the spacecraft work is that you've got 2 of them. They're both in exactly the same orbit around the Earth, but they're 220 kilometers apart. So one's leading the other one. And the really neat bit, and this blows my mind, Andrew, they're 220 kilometers apart, but at any instant, the separation between them is known to an accuracy of 1,000th of a millimeter. Wow. And it's because of that. So you're sensing the separation using microwaves, if I remember rightly. And then as one, the front one passes over something that's got a little bit more mass and therefore has a bigger gravitational pull, that pulls it forward a bit, and you can sense the difference, the change in the distance between them. And so by very clever computation, as these things orbit the Earth, you can build up a map showing basically the gravitational differences in over the Earth's surface. Now, the original GRACE experiment turned out to be really good at sensing what's called the hydrological cycle, the way water works on the Earth's surface. Things like the land changing shape after prolonged rain, ice melting and draining into the oceans, polar ice, things of that sort, and the movements of the oceans themselves. This is really fantastic stuff, but Grace is very, very good at that. And such was the success of Grace that this new version has been launched. It's called Grace FO. I suspect that might mean Grace Follow-On, although I'm not sure.
Could be something else.
I wasn't going to go there, but that's right. So there will be a period of kind of settling down to get the spacecraft into working condition. But I think we will find much more interesting information about our own planet coming from the Grace FO mission. And hopefully we might see some really spectacular results that relate to things like the way the climate is changing. The work that climate scientists are doing on the Earth will be reflected by some of the results that come from the hydrological cycle.
Yeah, and it will also, I'm imagining, be able to measure things like the diminishing amount of ice on Earth,
exactly.
Sea level rises.
Exactly.
I also believe it will be able to measure the changes in the land because of drought effect. Because
yes, that's right.
That's loss of moisture, and where I am at the moment, we've basically been drought declared for a little while now, and you can see it when you're outside. The ground is just parched. Just about everything's dead. Cracks are starting to appear in the ground, and that's simply loss of moisture. And Grace can look at wide areas that are suffering from that kind of a problem and come up with some very interesting information. Not that it can stop a drought, but it can at least look at what's going on.
That's right. But and this is actually one of the things that's come out of the new Australian Space Agency, a discussion of this kind of thing, because knowing about moisture in soil and things of that sort lets you develop strategies in order to compensate for that. So rather than just do things as you've always done them, there is perhaps a new method of using this information to do agriculture differently. And in fact, it's known, CSIRO are calling it precision ag. Precision ag is using space data and other data to be more clever about where you sow your crops, how you put them in, how close to water sources you build them, and things of that sort.
Yeah, well, we've got farmers around here that are dry sowing in the forlorn hope that it will rain.
It will rain.
It's
That's right.
a throw of the dice.
Yep.
And they're throwing craps, unfortunately. But you've got to make a decision. Maybe this sort of technology into the future will be able to say to them, okay, well, we are seeing signs of this happening longitudinally, and we don't think you should waste your money on.
Yes, that's right. That's the sort of thing. Exactly.
Yeah, fascinating. Yeah. All right. Well, those satellites have been launched. I suppose they'll be lining them up, sizing them up, targeting them, and making sure the microwave link works. And then we'll start to get some interesting data.
I hope we'll be talking about it very soon. Yeah.
Indeed. All right. You're listening to the podcast we like to call Space Nuts.
0G, and I feel fine.
Space Nuts.
As we tend to do in the last portion of the program, Fred, we're going to look at a question. But this is a question that has come out of something we talked about only last week from Tony Dawn, not to be confused with Tony Orlando and Dawn. And I think I've used that joke before. Thank you, Tony. After listening to the multiverse topic in your May 17 Space Nuts podcast and your discussion on dark energy being a description of why the universe seems to be expanding at an increasing rate, I had an image of the kids' toy slime, which can be seemingly quite solid under some circumstances, but quite liquid under others, and can seem to flow faster and faster. I believe that this is an example of a non-Newtonian fluid. Could the universe be considered as behaving as a non-Newtonian fluid? That's the question, part one. Part two, another thing that I began to contemplate after hearing that segment is whether the action of dark energy could equally be explained by a decrease in an as yet undetected attractive force caused by the expansion of the universe. That's a great question, and I got through it without a blunder. He says, I imagine others have worked through these ideas. Do you know what conclusions have been reached, and could you let me know? And I think I can say to you, Tony, you're going great until you said the word conclusions. But it's a two-part question. So, non-Newtonian fluid, Fred, do you come across this kind of idea?
Yes, I do know. I remember slime. I think it's an example of. It's an example. It's green, if I remember rightly.
Yes, it is. Yeah, I remember the stuff.
I think it's an example of what's called a thixotropic fluid, which is one that. It has a high viscosity until you start pummeling it or basically manipulating it, and then its viscosity changes and it becomes more liquid. It is a non-Newtonian fluid, and in many ways you could probably describe the universe as a non-Newtonian fluid, because the Newtonian laws simply don't work on very large scales. We rely on relativistic laws, because that's the sort of the theory of relativity with its emphasis on gravity is what really underlines our understanding of the universe. It's the foundation on which we build all models of what the expanding universe is doing. I think it's a fairly long bow to draw to make the comparison between a thixotropic fluid like slime and the contents of the universe. But often things like that serve as really good examples to illustrate what is going on and to perhaps, almost simulate some scientific features of reality. I would need to get my head around the details of slime to know just exactly what bit of the universe this simulates. But it's a good suggestion, which I like very much. I think the other part of Tony's question, is we regard dark energy as a sort of expansive force, but could it be a decrease in an as yet undetected
something else we don't know about?
Well, yes, that's right. So all the best science seems to indicate that there are a handful of fundamental forces in nature: the weak and strong nuclear forces, the electromagnetic force, and gravity. Those are the four forces we know about. And everything that we've done, all of physics, seems to say that, yes, everything can be reduced to those four forces. So if you were trying to indicate that dark energy was the result of a reducing attractive force, your only option, really, because it's the only one that works on these large scales, is gravity. And if you say, okay, well, the universe is full of objects like galaxies, and each one of them has its own gravitational pull, if for some reason that is decreasing, what would you see? And the bottom line is that you probably wouldn't see what we detect as dark energy, because if the gravity of an individual cluster of galaxies is decreasing, for example, you'd start to see that cluster flying apart, and it will be a local effect. That's the point I want to make. It will be local rather than a global effect. And the key thing about dark energy, and perhaps, in some ways the most surprising thing about it, is that it's everywhere. And it seems to be the same everywhere as well. It seems to be a completely uniform thing. Whatever it is, we don't understand what it is, but we do know that as space expands, dark energy expands too, so that if you've got space doubling in volume, then the dark energy doubles, which is bizarre. So it's something that is a property of space itself and not the matter within it. I think that is probably all we can say at the moment about that in its relation to a potential attractive force that's decreasing. It's a great suggestion, but yes, people have sort of looked at those prospects before, and we still come back to the idea that dark energy is a property of space, and it's a weird one.
It's probably going to take some significant out-of-the-box thinking to really figure out what's going on, and maybe we'll never know. Maybe it's just going to be one of those mysteries that we just can't unravel. We just haven't got the capacity to do it, or maybe we haven't developed an instrument that will enable us to really get an insight into it. We talked about multiverse theory and how they tipped a bit of water on it last time. But let's assume for a moment multiverses do exist. Could it be that our universe is feeding on another?
Yeah, that's another one of the ideas, that you've got some sort of interactions between different universes. But if that were the case, you wouldn't you kind of would expect something asymmetric, something pulling one way rather than space itself just expanding. But these ideas, and particularly ideas that involve the multiverse, they're so vague is the wrong word. They're ill-defined, they're ill-constructed, because we haven't really got to grips with the kind of physics that you need to describe a multiverse and what the effect of one universe on another might be.
I'm making an assumption that they all, if they do exist, they exist like they cohabit.
Maybe
so that they're next to each other. But who's to suggest that that's the case? They might all be overlapping and intermingled.
Exactly.
Interdimensionally.
Yeah, that's right, because you're probably looking at higher dimensional spaces anyway. This conversation, Andrew, is now formally the blind leading the blind.
But it creates interesting thoughts and debate.
It does, that's right, absolutely.
That's half the time that's what it's about, because we don't have the answers. So you start throwing around ideas and you think, well, okay, that could be the case. Then you investigate that and go, nope.
Yeah.
Or yes.
That's right. And what I was going to say, I am pretty confident that we will find an answer to dark energy that will fit, all that we understand about the universe. And the reason I say that is I'm surrounded by colleagues who've got such interesting and, as you say, out-of-the-box ideas about how you can test for different things that I would never have thought of, because I make things out of fibre optics and bits of string and sticky tape and things like that. These guys are devising experiments that would test between different models of, say, a multiverse or a single universe. And that's where science is going. That's the beauty of science, that ingenuity often leads to very clever answers.
Well, we can never say never to anything. I mean, if you go back a few hundred years and say to Christopher Columbus or James Cook, hey, you won't have to do this in the future because you'll be able to go into a machine and they will fly you across the ocean.
Yeah,
They'd throw you overboard.
In your dream.
Yeah. So, who knows what's next? Who knows what we're going to discover? It's
Exactly.
That's what makes it so exciting.
Indeed. Absolutely.
Well, Fred, I'm going to let you get some sleep, because it's been a long couple of days and it's not over yet. But by the time this podcast is published, you'll be in a cocoon somewhere, I think.
I hope so, yeah.
But
thanks, Andrew. Great
hopefully we can talk to you next week.
Yeah, sounds good.
Fred Watson from the Australian Astronomical Observatory. Keep your cards and letters and emails and posts coming in via whatever platform you deem necessary, and we look forward to joining you again on the podcast Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.